Hello everyone, I am Mauli Raj, Assistant Professor, Department of Computer Science and Engineering, Sri Shanmuga College of Engineering and Technology. Today we have see about data structures, searching and sorting. Okay, sorting algorithms. We have see about the next slides. Searching techniques. Searching is the process of determining whether an element is present in a given list of elements or not. If the element is found, then the search is successful. Otherwise, it is considered as an unsuccessful search. Next, we have see about linear search. Linear search is the simplest searching techniques. The search begins at the one end of list and searches for the required elements one by one until the element is found or till the end of the list is reached. The example 3, 12, 18, 33, 21, 5, 99 and 42. The key is the 32. We have reached some find the values up to search and find out the some particular values. This is the routine the example program of given the linear search. Next we have analysis. Best case means 1. Average case equal to 1 plus 2 plus dot n divided by 2 equal to n plus 1 divided 2n equal to on. Advantages simple. It does not require the list to be stored in a particular order. Disadvantages inefficient for large sized list. Next we have see about binary search. Binary search requires the list to be stored in ascending order. The binary search algorithm begins by comparing the element that is present at the middle of the list. If there is the match, then the search ends and the location of middle element is returned. If there is mismatch which with the middle element and the search element is less than the middle element, then first part of the list searched, otherwise second part of the list searched. The process of continues until the search element is equal to the middle element or the list contains only one element that is not equal to the search element. The key equal to 4. The given value is 1, 3, 4, 6, 8, 9, 11. Okay, compare the key middle element 6 not equal to 4 and 4 less than 6. So search first list 1, 3, 4 the first and 6, 8, 9, 11. So we have find out 1 and 3 and 4. 3 not equal to 4, 4 greater than 3. So search second list where 4 equal to 4. So search is unsuccessful. So search is successful. Next routine, the program binary search int a of int key into big int end int mid. If big greater than end, return 1, mid equal to big plus n divided by 2. If key double equal a of mid return mid, else if key a less than a mid, return binary search a comma key comma big mid minus 1, else return binary search a comma key mid plus 1 end. Okay, efficiency best case of 0 of 1, worst case 0 log n. What are the advantages? Require lesser number of instructions, faster than linear search. What are the disadvantages? List to be stored before search operation. Next, sorting techniques. Sorting is the process of rearranging the given elements into the either ascending or descending order. There are two types of sorting techniques: internal sorting and external sorting. What is meant by internal sorting? If sorting operation is done in main memory of computer, then it is called internal sorting. Example: bubble sort, insertion sort, selection sort, quick sort, radix and heap sort. External sorting: if sorting operation is done in secondary memory of computer, then it is called external storing. Multi-way range and polish of mesh. Okay, next we have see about bubble sort. Bubble sort is the order sorting method. It is also referred skinning sort procedure. It is repeatedly move the smallest element to the lowest index position in the list. It repeatedly compare two consecutive elements and moves the smallest among them to the left. This process is repeated until all the elements are in the same correct order. Okay, the given example 56, 91, 35, 72, 48, 68. Page 1 we have 0 to 5 index. Here compare the first value to minimum value. Okay, 56, the compare the 56 the lesser value means 35. So we have swap the 35. Next we have compare the 56 to 72. Okay, so no changes. Next 56 to 48, no changes. Next we have to 56 to 68 means no changes. Next we have rearrange the values. 35 the index 2 is replaced to index 0, and index 0 is replaced to index 2. Okay, next page to 35. Next we have compare the 91 to 56. The 91 is greater, 56 is lesser, so 56 swap to index 1, 91 is swap to index 2. Okay, next we have compare the 91 to 48. 91 is greater, 56, and compare the 48. So 48 is lesser, 56 is greater, so we have index 4 is swapped to index 2, index 2 is swapped to index 4. Okay, next we have 35 and 56, 91 is replaced. Next we have page 3, 35, 48, 91, 72, 56 and 68. Next we have swap the 91 and 72. 91 and 72 means we have index 3 is swapped to index 2, index 2 is swapped to index 3, and 35, 48, the 91 is moved to index 3, and 72 is moved to index 4, and 91 is 56 moved to index 2. Next page 4, 35, 48, 56 and 68, 91, 72. We have swapped the 3, 4, 5 index values. Page 5 we have 35, 48, 56 and 68, 91, 72. Next we have last page we have swapped the index 4 and 5. Okay, 72 is for swap to 4, index 4, and 91 is swap to index 5. So finally get the ascending to descending order: 35, 48, 56, 68, 72 and 91. Next we have routine. This is the example program of bubble chart. Next one, selection chart. Select the smallest element in the list. When the element is found, it is swapped within the first element in the list. Then the second smallest element in the list is the searched. When the element is found, it is swapped with the second element in the list. This process of selection and exchange continues until all the elements in the list have been sorted in ascending order. This is the example program. This is the first we have unsorted list. Next we have select and sort. 56 to 35 we have sort and swap the values. We have finally answer is ascending to descending order. Next we have move over to insertion sort. The simplest sorting techniques in insertion sort. Insertion sort performed n-1 pages. For pause p equal to 1 throw n-1. Insertion sort ensure that all the element in the position 0 throw p or in store in sorted order. In pass p we move the element in the position p to the left until its correct place is found. Next, this is the example program. The element in the position p is saved in the temp, and all large elements prior to the position p are moved one spot to the right, then temp is placed in the correct spot. This is the short numbers 34. We have after p equal to 1, after p equals 2 means compare the index value and move the position. This is the example of insertion sorting. Next, shell sort. The shell sort is invented by the Donald shell. It works by comparing elements that are distant. The distance between the comparison decreases as the algorithm runs until the last page. In the last place adjacent elements are compared. So shell sort is also called diminishing increment sort. The shell sort use a sequence h1 h2 or up to ht is called the increment sequence. After the page some increment hk for every I, a of I less than equal to a of I plus hk. Then that is all the element space hk apart are stored. So the file is said to be hk stored. The increment sequence suggested by shell is hk equal to n divided by 2. This is the example program. Next we have a compare the second page, the third page and first page. Okay, next one, merge sort. Merge sort use divided and concave method. The problem is divided into smaller problems solved recursively. Finally, it measures two shorter lists. Basic algorithm: divide the given array of elements into two halves. Recursively sort the first half and second half of array elements. Take two input arrays A and B and output array C. The first element of A array and B array are compared, then the smaller element is stored into the output array C. The corresponding pointer is incremented. This step is repeated until all elements are compared. This is the example of merge sort, we have 8 elements divided into 4 and 4, and divided 2 by 2, 4 elements divided by 2 by 2, and 2 is divided by 1 1. And again we have repeat the same concepts of merge the single values of two values connected with 4, and finally we have ascending order to descending order. Let us consider the 4 elements of our input array A, and next 4 element or input array B, APTR, BTR and CPTR, which are initially set to beginning their respective arrays. This is the examples of we have compared the how to one by one processes in 4 8 4 divided by 4 divided by 4 4, and 4 is divided by 2 2, and 2 is divided by single elements. Okay, this is the examples. This is the examples algorithm merge sort, and this is the program. Thank you.